तो आज हम लोग एक प्रॉब्लम डिस्कस करेंगे, मैथमेटिकल प्रॉब्लम, जो रोल्स थ्योरम और लैग्रांज मीन वैल्यू थ्योरम दोनों पर बेस्ड है। पहला रोल्स थ्योरम और दूसरा लैग्रांजेस मीन वैल्यू थ्योरम। ओके, तो आप सबको तो पता ही होगा रोल्स थ्योरम क्या है और लैग्रांजेस मीन वैल्यू थ्योरम क्या है। हम क्वेश्चंस के बीच में जो है, इसके सॉल्यूशन के बीच में डिस्कस कर देंगे अगर नहीं पता हो तो क्वेश्चन यहाँ कह रहा है कि एफ कोई कंटिन्यूसली डिफरेंशिएबल फंक्शन है क्लोज इंटरवल 0 to 2 में, और ट्वाइस डिफरेंशिएबल है ओपन इंटरवल 0 to 2 में। एफ ऑफ 0 0, एफ ऑफ 1 1 और एफ ऑफ 2 2 दिया हुआ है। देन देयर एग्जिस्ट एक्स नोट बिलोंगिंग टू 0 to 2 सच दैट डबल डेरिवेटिव ऑफ एफ एक्स नॉट इज इक्वल टू 0। तो हमें इसे दिखाना है कि ट्रू है या फॉल्स है। ओके, नाउ फर्स्ट ऑफ ऑल वी आर गिवन, तो हम इसे मिटाते हैं पहले। नो, एक्सक्यूज मी। First of all, what are we given here? There is a function f which is given to be continuous on closed interval 0 to 2, and second differentiable on 0 to 2, closed interval 0 to 2. Okay, as we know the Lagrange's mean value theorem, Lagrange's mean value theorem says that if a function f Lagrange's mean value theorem, what it says, how to scroll it yaar. ओके, अब समझ में आया कैसे स्क्रॉल किया जाता है। सी it says that if f is a continuous function, continuous on closed interval ab and differentiable on open interval ab, okay, then there exists a point C, there exists a point C on open interval AB such that f dash of C is equal to f of B minus f of A by B minus of A. Okay, this is the statement of Lagrange mean value theorem, as we all aware of this. Now we will use this theorem here on the given function. Okay, let me erase this first. Now see, you can see that f is a continuous function of 0 to 2. It is given. It is also differentiable on that interval. It is differentiable on the closed interval. That means it also differentiable on the open interval 0 to 2. And it conclude that we can break the function on two interval, 0 to 1 and 0 to 2. Okay, function is continuous on 0 to 2. That means first part function will continuous on 0 to 1. Since it is continuous on 0 to 2, then it will continuous in any interval, sub interval of 0 to 2. Okay, also differentiable on open interval 0 to 1. Okay, so by Lagrange mean value theorem, there exists C1 belonging to open interval 0 to 1 such that f dash of C1 is equal to f of 1 minus f of 0 by 1 minus of 0. And what is f of 1 is 1. It is given. You can see here f of 0 is 0, f of 1 is 1, f of 2 is 2. Okay, then f of 1 is 1, f of 0 is 0, this is 1. F dash of C1 will equal what? 1. This is equation number 1. Let's consider it. Similarly, we will see that the same function is continuous on closed interval 1 to 2. Since it is continuous on 0 to 2, it means it will continuous on any subinterval of 0 to 2, and 1 to 2 is a subinterval of closed interval 0 to 2. So function will continuous on closed intervals 1 to 2. Also it is differentiable on open interval 1 to 2, and hence by Lagrange mean value theorem we will get a point C2 belonging to 1 to 2 such that f dash of C2 will equal f of 2 minus f of 1 by 2 minus of 1. Satyanas. Okay, and after putting all these values you will get f dash of 2 is equal to also 1. Okay, consider this equation, equation number 2. Okay, now we what we get 2 points C1 and C2 that belongs to open interval 0 to 2. Okay, ओपन इंटरवल 0 to 2 के बीच में ही ये लाई करता है. C1 ओपन इंटरवल 0 to 1 और C2 ओपन इंटरवल 1 to 2. ओके, सो ये दोनों जो है ओपन इंटरवल 0 to 2 के बीच में लाई करेगा. इसको और क्लियरली लिखते हैं हम अगर तो ऐसे लिख सकते हैं. ओपन इंटरवल 0 to 1 यूनियन ओपन इंटरवल 1 to 2 इसमें जो है बिलोंग करता है। ठीक है, तो और क्वेश्चन में हमें क्या दिया गया था? Twice differentiable function is given to be twice differentiable. Very interesting. Now we will use the Rolle's theorem. Now let gx is equal to f dash of x. Then what can we say about gx? Function f is twice differentiable. Okay, what can we say about the nature of gx on the closed interval c1 to c2? Since it is given that f is double differentiable, okay, twice differentiable on open interval 0 to 2, okay, ओपन इंटरवल 0 to 2 में एफ डैश ऑफ एक्स क्या डिफरेंशिएबल है, और c1 इसी के अंदर है, c2 भी इसी के अंदर है। ठीक, तो c1 और c2 इंटरवल पे फंक्शन डिफरेंशिएबल हो जाएगा, क्योंकि 0 to 2 पे डिफरेंशिएबल दिया हुआ है। तो जो gx है, it will differentiable on closed interval c1 to c2, and as we know that differentiability implies that it is continuous. Differentiation is a sufficient condition of a function to be continuous, so it will also continuous on closed interval c1 to c2. Okay, now from equation 1 and 2 we have g of c1 that is equal to g of c2 that is equal to 0 using above equation 1 and 2. You can see that f dash of c2 it is 1 and f dash of c1 that is 1. Okay, f dash of c2 that means g of c2, or f dash of c1 that means g of c1. Hence by Rolle's theorem we can say that, hence by Rolle's theorem there exists a point c3 from the closed interval c1 to c2. Okay, and this closed interval is a sub interval of 0 to 2. Okay, if we say that it is sub interval open interval 0 to 2, okay, such that g dash of c3 equal to 0. G dash of c3 that means what? First of all, g of x is equal to f dash of x, that means g dash of x is equal to f double dash of x. So g dash of c3 is equal to f double dash of c3, and hence f double dash of c3 will be equal to 0, where c3 belonging to open interval 0 to belongs to open interval 0 to 2. And that's what is we have to prove, no? That is what we have to prove. Hence the given statement is true. Hence given statement is true. Okay, thank you.